Hello friends, today I'm going to solve LeetCode problem 938, range sum of BST. So here we are given a binary search tree, and we are given the root node of the binary search tree, the two integer values low and high, and we need to return the sum of all the values of the nodes whose values are in the range low and high. So let's see how we could solve this problem. So we are given this binary search tree and we are given a range low and high, so we need to return a sum where all the values where the values of the node lies in the range high and low. So it's an inclusive sum, so this property should always be satisfied, this condition. So if this condition is satisfied, that is only when we add the value of the node to our sum. So this is what we are going to do if this condition is satisfied. Now the point here is like, how are we going to traverse this tree, because we need the values of each of the node, right? We need to check the values of each of the nodes with the left and the with the low and the high range, right? So how are we gonna reach each of the node? So basically what we could do is we just need to traverse the tree in one way or another. So the easiest would be or to use the depth first search. So I'm going to use depth first search to traverse this route and this tree. So depth first search means we move from a given node, we go to the left, and then of that left subtree, so basically from a given node we go to the left subtree, and then that subtree, or in that subtree we do the same thing again. So basically here, this whole tree, we start from this node and then we move towards the left of this node. So this becomes our new subtree in towards the left when we move towards the left. This is our subtree here. Now in this subtree, the root node is this one, right? So we reach this root node, and then from this root node as well, again we go towards the left subtree. So this becomes our left subtree. Now this single node is also a tree, so when we try to move to the left of this subtree of this node, root node, the value, there is no root node here, right? The value is equals to null. So when the value is equals to null, we return back to our root node. We try to move towards the right, the value again is null, so we return back from here, and then we return to our previous root node, and then we try to move towards the right, and then we do the same for here, for this also. So we try to move towards the right, and for this right subtree, again since it is a tree, we try to move towards the left. Since there is no root, there is no nodes towards the left, we then move towards the right, and on each move we keep on checking the values of the node, and if the value lies within this range, then we add to our sum, else we just keep on moving, and at the end we return our sum. So let's code this solution. So what we need is, we need the value sum, which we will be returning at the end, and now we need to create a DFS solution. So I'm just gonna create a function, DFS function here, and then we also need to check if we need to pass in a node here, and we need to check if the node is null, then we are going to return back to our previous node. Else, if we are again going to check if the value of the root node is greater than equals to the lower range, and the value is less than equals to the high. If this condition is satisfied, then we add to our sum the value of the node and then we move towards the left of the node, and then we move towards the right of that node. So that is how we'll be doing this. Let's try to run our code. Oops. Okay, so one mistake I did is I did not call my DFS function. So we are gonna call the DFS function from the very root of our tree and run the code. Cool, let's submit it. So the time complexity of this whole function would be big O of n, because we are iterating over each of the nodes of the tree. So it's O of n, and the space complexity is a constant space complexity.